This is the overall setup of the wearable ultra low power protection system for coal mine workers. This system comprises of two units, namely the miner unit and the ground unit. This is the miner module, which can be attached with the body of the worker working in the underground mine. The size of this module can be miniaturized when it is designed as an industrial product. This miner module consists of various sensors such as fire sensor, LDR, humidity and temperature sensors, fall detector and gas sensors to sense fire, detect light and temperature and humidity values, and to find the position of the worker and the presence of toxic gases in the underground mine area. This is the ARM7 LPC2148 microcontroller, the heart of the system. All the sensor outputs are given to the microcontroller. If the received parameter values exceeds the safety pre-programmed in the microcontroller, then it alerts the worker through alarming the buzzer and displaying the warning messages in the LCD display. The microcontroller also alerts the ground unit by using the RF transmitter and the GSM module simultaneously. The RF transmitter is used to send the parameter values and warning messages to the RF receiver in the ground station. The received messages will be stored in the PC. The GSM modem is used to send the warning messages to the fire and ambulance service stations simultaneously. This is the ground unit located in the ground. This unit consists of control station and service stations. The RF receiver and the PC are located at the control station to receive and store the warning messages from the miner unit. Two service stations, namely fire and ambulance service stations, are situated near the control station. These stations receives the message from GSM module in the miner unit.
Now let us see the demonstration for the miner module in this wearable protection system. When the microcontroller detects any issues in the received values sent from the sensors, it alerts the workers in the mine unit by using alarm and the LCD display. It also alerts the ground station by displaying warning messages in the PC and sends the SMS to the fire and ambulance service stations to take the necessary rescue actions. This is the temperature sensor. When the temperature value changes from human comfort range, then it will start alerting the worker, ground station and the service stations. The human comfort range is 20 degrees Celsius to 26 degrees Celsius. Now the temperature range is 28 degrees Celsius. So it starts alerting the workers. This is the humidity sensor. When the humidity value changes from human comfort range, then it will start alerting the worker, ground station and the service stations. The human comfort range is 30% to 80%. Now the range is 10%. So it starts alerting. This is the LDR. It is used to sense the darkness in the underground unit. If the light intensity level is reduced in the working area, then the LDR triggered circuit will turn on the LED. For the demonstration purpose, I am covering the LDR using a cloth to create the darkness. Now the LEDs will be turned on to provide light in the underground mine area. This is the 3-axis accelerometer. Find the position of the worker. This is the IR-based flame detector. When the flame detector detects any fire in the underground unit, then it starts alerting the worker, ground station and the service stations. This is the 3-axis accelerometer which is used to find the position of the worker. This is the normal position of the worker. When the worker falls down, then the controller starts alerting the ground and the service stations. These are the gas sensors MQ4, MQ5, MQ6 and MQ7 to measure the toxic gases methane, hydrogen, propane and carbon monoxide respectively. When the concentration of the toxic gases values changes from human comfort range, then it will start alerting the workers, ground station and the service stations. The gases we discussed before are the most toxic gases present in the mine area. As per the recommendation of the Pollution and Control Board, we are not supposed to use the toxic gases for the demonstration purpose. For the demonstration purpose, I have used thinner for the toxic gases. Now I am using thinner for the hydrogen gas detection purpose. As the value of the hydrogen gas increases from the human comfort range, then the microcontroller will start alerting the worker, ground station and the control stations.
Here I am using thinner to demonstrate the working of the gas sensor. As the gas value exceeds the safety level, the controller starts alerting the ground unit and the worker.
This is the ground station. The RF receiver in the ground station receives all the messages from the RF transmitter in the minor module and sends to the PC using the serial communication. This is the data stored in the PC. Using this data, we can save the workers.
This is the fire service station where the alert messages are received. This is the ambulance service station where the alert messages are received. In case of fire accident or toxic gas emissions in any of the underground units, there is a chance for the vigorous disaster. At this situation, the supervisor in the control station can guide the workers in the affected and nearby mines to exit the perilous affected area in a safe and shortest path using the data stored in the PC. By using these features of the system, we can save the workers easily.